welcome to this short introduction on pops. Pops is an operator family, like this box right here, and that works a lot with points. So we see that this box consists of 8 points, but we can also have the primitives or the vertices. So if we look at it in this way, so this quad or quadrilaterals is made of different vertices. So 0 is 1, 0, 4, 5. And we can see, okay, we have this 0, 1, 2, and 3. And this is primitives v index, so primitive 0, index 0, primitive 0, index 1, and so forth. Then we have p index, so that's the points actually. Then we have the normals, now calculated on the vertices, and now we have textures. So in this moment, if we look at the box and we toggle wireframe, so we do that by activating this and toggling W, then we can see that we have this box that consists out of vertices and of faces. So now we can see we can actually change this. So connectivity to triangles. So now they are connected with triangles. We can do the point primitives. So then we have actually 8 points. And we can have no connectivity, which means we only have the points. So then we can change the corner radius, but of course then we will get a lot of more points and vertices and quads here. We can change the anchor, we can translate, rotate, uniform scale. We can decide on which attribute the normals are calculated, so we can move that to points. So then we see that it has gone here and move to the points. So now we have a normal for every point that we have. We can also do it with the texture coordinates. We can also say, okay, we don't want any texture coordinates. But for now we can leave it at vertex. Then we have a texture method. And these are different settings to calculate the texture. And at this moment we don't have a color, but we can introduce it, and I will actually turn the radius on, off, because now we have a color on points. Now we can have a color on our vertices or on our primitives. Let's say we want to create an attribute, and then we can right click and go to attribute or attribute combine. So now we will actually create an attribute, and I will move this to view what we are doing right here. So attributes, we can select to attribute class points. Okay, and we can have a different attributes. So we want maybe some velocity. Now we have velocity 0. So now we can say, okay, we want float, double int, uint, unsigned int, color, double direction, or direction double. And now we can say, okay, we want 1, 2, 3, or 4 channels. In this case, we want maybe 3 channels, because we want to have a velocity in every direction. And then we can say, okay, we want noise. The noise lookup attribute is the point, and the output is the velocity. And so now again, if we select this one, we see that the velocity has a random value. So just to compare, here it's all 0, here it's random value. And then we can say we want a transform. We want the weight attribute to be the velocity. And then we want to have this 10. And now it's based on the first velocity, and we will translate it into this direction. So that's kind of how this goes. So we can create an attribute, then add noise to it, or add a value to it. So actually, if we change this, so now we get a seed. We can increase the amplitude, then you see this gets bigger or smaller. Exponent. So this is actually what can do with the attribute, noise, and transform. Then we can create, or we can combine this. So let's first okay, and then we can actually rename these. So then we can combine these by selecting here. So input pops, input attributes, we have the P and we have the velocity. And then we can see if we do a pop2, that's okay, let's call this test. So now we have another attribute that we created with tests and the values of the p tag, because we wrote it here. So that's something that we can do. So in the pop operators, we have a sphere, kind of the same as a box, and you can kind of find the parallels between the sub. So we have a box here as well, and we have a sphere there as well. But the thing is, the main difference is that this is super optimized, and we can have a lot of points. So this is a sphere, this is a sprinkle. So we create point primitives on the seed of 1, method per primitive, we can do in volume, and these are 10,000 points. So now we can add some noise. Now we see that this noise is on the P, and we combined attribute scope, so that's also on the p tag. So now we see the displacement happening in real time, and then in transform we can say, okay, we want this to move. So now we have something that is moving. Let's say we want to render this for now. So basically what you do with the subs, you do the same with pops. So what you can do is actually we have geometry, and then we will have light, camera, and a render. And so now we see that we have something happening here. We can actually do some materials. I will do a point sprite and a thong and a switch and a null, so we can see the difference. Okay, so this null will be the material. So now we actually see the influence of the thong. And then we can switch to the point sprite, which is actually more solid. And now we can increase or decrease the scale. But now they are all kind of boxes. So what we could do is actually, instead of going here and with subs we used a lot of instancing. Now we can also do something that is called copy. And we want maybe our sphere. I will transform it so it's a tiny bit smaller. Like so. And then we can actually increase this. Oh, way too big. Okay, so now we have these little spheres floating with the copy. And then the problem that we had with subs was that we cannot combine different instances together, and this is now a possibility. So what we can do is actually create maybe a circle. So now we have a circle that's lying flat, and then we can say, okay, we want another copy of this, and on every point of that circle. And you see that my GPU is kind of not liking it at the moment because there's way too much divisions. Let's say we want 3, and we want to have some noise. Okay, this is way too fast, like this, and then you see that these are like moving. Very beautiful. But you can, like, actually, this is kind of the alternative to an instance right now. If you want to work with attributes, instancing has its advantages too. But now we are working like with a lot of attributes, and then we can just say, okay, want to copy this on these elements. So actually, if I do point primitives, that would be fine as well. you don't need here the line strips. But the difference between a line strip and a line I can explain shortly. So again, we do the pop to dots, and I will actually do the primitives. So line strip is actually consists of 4 different vertices, and we can completely close it. So it will be 0, 1, 2, 0. And if we do lines, we have actually multiple lines. So then we have 0 to 1, 1 to 2, 2 to 0. I don't know the indices by heart here, but yeah, just 3 different lines between difference between a line and a line strip. So that's about it. The only thing that I want to mention is that there's also a point generator. So then we can have a sphere. I will actually bypass this copy for now. So give my GPU some rest. So we have a shape of sphere. Then we can have a torus. We have 10,000 points. We can do volume or surface. We can have an orientation, normal again on the point, default and tangent off. And these are like all the things that we can do. So if you want to have that being copied here, then we see that we all have these points on a torus. Again, here we see that we have some options. So we have the P and the N. So the normal is on the points, and the normal is just the vector that points outwards or perpendicular to the point itself. And what is useful is if we go to palette and we have in the pops channel, we have a point render. We have a viewer, sorry. And then we can actually drag this on top. And then we can select this. And we can select here, we can have the points. This is B0. We can have the, this is at the moment, we can have the normal vectors. So now you see how these are distributed. We can have 2 different ones, so we can have the P and the normal, and then we will have the P again. So now we can select here which one we want to show. And that's kind of it. So if you see here, this is the point and the normal vector. Actually, maybe I want to only have 1 point now. Maybe 10. Oops, what is wrong here? We'll just introduce that again. Okay, so 10. And now I want to have the points, the P and the N. And so now you see that this would always be 90 degrees on the other surface. So that is kind of it. As introduction, so now there's plenty of tutorials out there that use these methods to work with pops. I think this can be very handy, very useful, but you need to learn to work with the attributes, which is kind of sometimes a new way of thinking. So good luck.